So just on the whole notion of packet-based, I just wanted to just for a second talk about that, just because I think a lot of people don't often know where OmniPeak and packet analysis really fits in, right? In a lot of cases, people think, well, there's already wireless LAN monitoring, with my access points, with my operating system from my wireless LAN controller. Why do I need packet-based analysis? Well, part of what I'm trying to equate it to is, well, you certainly wouldn't go without spectrum analysis. Everybody understands the benefit of spectrum analysis for layer one. And a lot of times it's the first place you're going to go troubleshoot. And really with packet analysis, it's just the next layer up, right? More so even than wired networks, you're going to have packet problems in wired networks. You drop packets, there's retransmissions, there's much more of that happens on any sort of wired network, and you definitely need packet level analysis rather than just monitoring. Monitoring is great for telling you how many people are using N, how many people are using AC, and what's the bandwidth, but that's not going to solve the detailed problems for you. So I think what people generally have, what's in your toolkit, it's spectrum analysis, it's site survey, and it's protocol analysis like OmniPeak, and oftentimes, it is exactly this set of products, right? It's MetaGeek Channelizer, and it's Ekahau, and it's WildPacket. So, just wanted to get you thinking in that way. A little bit more about, why packet, few examples, and these are real customer examples that came in. I've kind of, changed the names and the devices to protect the innocent because there were real specifics in here, but, here was an environment where it was a warehouse environment, and, every device is working in the environment except for one type of device, and every one of those devices is not working well. They're locking up, they're freezing, they're timing out. And at the time, this was a year or two ago, the only clue was that the problem device was the only device on 11N. So at least it helped give them some clarity, some direction as to where to go look. But highlighting that need for packets, what they ended up finding was, it was not a simple problem. It wasn't just a simple connectivity problem or something else. There was really a problem in the protocol where 11N protocol really wasn't being followed. And you can even see it down in here, right? The problem devices were not acknowledging block ACKs. So after several requests, the APs would de-auth the devices. They'd go look for another AP. They wouldn't acknowledge block ACKs. They'd get de-auth. They'd go look for other APs, and it was just taking care of the entire network. And all these devices. So it just highlights that need for packet analysis. You can see it very clearly in packet analysis, right? Four bars, nothing, and then a de-auth. So just one of several examples about needing packets in a hospital environment. Same kind of thing. The physicians, they want to use their own devices. They always want to use the very latest and greatest devices, but yet a lot of them are experiencing slow response time. Again, real life problems. What is protocol analysis showing the network engineer? Well, there's probe requests are going out to all SSADs rather than just one. ARP requests are going out too frequently. Send out multiple ACKs in response to the same incoming packets. CTS frames and null data. Timings that are way off. Association and reassociation requests with long power save intervals. All things again you're not going to see unless you use packet-based analysis. And this is from a real device. And like I say, names hidden to protect the innocent. If anybody's done any work on this device, you'll know what these are. And some of this has probably been fixed, but certainly when they were first introduced and people were using them in this environment, there were a lot of problems and a lot of wasted bandwidth from these things that were going on. And lastly, another example with packet-based is in financial. A user of ours is actually using not just OmniPeak, but OmniEngine, which we're going to talk about here in a bit, in terms of doing distributed to do mission-critical financial trading. It is a trading floor. They have hundreds of users on the floor, hundreds of simultaneous trades, very high-end trades, and it's the kind of environment where, as a network engineer, you do not have the luxury of somebody calling you while the problem is happening and walking over to them and working with them while the problem is happening. It doesn't work that way. These guys are trading from their own devices. It doesn't work. They put it down. They pick up another device. Not working. Put it down. Get frustrated. Go to a wired connection. Make the trade. Now they're pissed off because the price has changed. And then at the end of the day, they're calling the network engineer and saying, "Hey, 2 o'clock to 3 o'clock, I just couldn't get any wireless connectivity at all from these devices. What was the problem?" And without storing packets, without having packets, number one, and archiving those to disk, you have no clue. So, and you don't want to repeat that same problem tomorrow, because I'm sure this fellow who couldn't trade is pretty unpleasant about the fact that it cost him money. So a solution like ours allows them to be able to, when you're using our engines, which is a kind of a distributed version of OmniPeak, allows them to be able to save the packets to disk on an ongoing basis. They can go back at any time and look at those packets, see exactly what happened, try and resolve that problem for these customers, and also even get to things like, did the trade actually happen? Maybe the trade did go through, or it also allows them to see things like latencies for the end users, which are very important in these financial applications. So just another example. So real quick, just one other quick example on why the packets can be important, and hopefully OmniPeak is still kind of going okay here. Not necessarily strictly a wireless example, but also using OmniPeak and using our expert events. Expert events can lead you to the root of problems, packet-based problems, often very quickly. So what we're looking at from within OmniPeak is we're looking at one of our expert areas. It's categorizing all of our flows by applications. Hopefully pretty straightforward. And then you see these are all the applications here, and we have an error, a SQL Server client error, which I've chosen to highlight it as the most severe. And the nice thing about the workflow, we've talked about that in OmniPeak before, is I can just go and highlight that particular event, and it will show me exactly what application, what server, what client, what flow that's even happening in. So very quickly, I isolate a problem. And then if I want to isolate it even more quickly, I can just right-click and then say, you know what, I just want to see the packets for that particular flow ID. And I've been running captures and being connected to engines, so I might need to restart. But so it'll stick those in a separate window for me. It's going to come up with just a couple of packets, I think. And then what I'm able to see is, I didn't get exactly there this time, but I'm able to see in the decodes exactly where and exactly what those problems are. I actually should have searched differently. My apologies for that. So just go back there one other time. Go back to here. Oh, sorry. What I really want to do is this. All right.
Yes.
Oh, sure. So here what this is going to do is it's going to isolate just the two packets for me that were involved in that expert event. And this is where things get important. So when you look down here in the packet payload itself, again, highlighting why packets are important, it shows me exactly what the error condition was. And it's probably not something that, certainly not something the user would see. It's probably not something the application was seeing. So it just shows that value of packets.